Mental strategies for subtraction. Using related facts. Knowing one addition fact means you also know two related subtraction facts. Because 7 plus 3 equals 10, you also know that 10 take away 7 equals 3 and 10 take away 3 equals 7. Bridging to 10. A 10 frame is useful to show the bridge to 10 strategy when subtracting. Here are 17 dots in two tens frames. When you see 17 minus 8 equals something, cross out 8 from the first 10 frame, then add what is left. Therefore, 17 minus 8 equals 9, as you can see here in the tens frame. Another example of bridging to 10 is using this number line system again. 25 minus 16 equals 9. We start at 16, we add 4 to get to 20, and then we add another 5 to get to 25. Therefore, 25 minus 16 equals 9. Counting on. If there's only a small difference between the numbers, use counting on to find the difference. See, 32 minus 28 equals something. We start at 28 and we can see that there's 4 to get to 32. Therefore, 32 minus 28 equals 4. Jump. When we subtract, we can use the jump strategy to help us. Look at 99 minus 42. We start at 99, we subtract 10 to 89, then we subtract another 10 to get to 79, another 10 to get to 69, and another one to 59, and then we minus the last two to 57. Therefore, 99 minus 42 equals 57. Split. When subtracting large numbers in our heads, it can be easier to split the number to be subtracted into parts and work with each part separately. 255 minus 132. The 132 gets separated into 100, 30 and 2. Therefore, 255 minus 100 equals 155. 155 minus 30 equals 125. And 125 minus 2 equals 123. Therefore, 255 minus 132 equals 123. Compensation. Sometimes we round one number in the problem to make it easier to do in our heads. Then we adjust our answer to compensate. 125 minus 49. We round the 49 up to 50 by 1, so we have 125 minus 50, so 75, and we have to add the extra 1 at the end, which equals 76. Bump. The bump strategy is when the number closest to 10 gets impatient to start the subtraction process. The other number must adjust to compensate. Here we have 65 minus 22. We take away 2 from the 22 so that it becomes 20, and we must do the same to the other side, 65 minus 2. Therefore, we have 63 minus 20 equals 43. That's the end of my presentation. Crystal will now go on to continue talking about subtraction and estimation within the primary school setting.
Now we're going to go on to subtraction using the decomposition method. Teaching students subtraction at a level 3 means that by completion they should recognise the connection between addition and subtraction. Here it shows basic addition and subtraction facts that demonstrate the inverse relationship between the both. They will also need to know how to complete number patterns with addition and subtraction. For example, the first one, 1, 10, 3, 12. Now the pattern here is plus 9, take away 7, plus 9, take away 7. These are basic things the students need to know to be able to complete the decomposition method. Things they'll need to know as well are models, language, symbols, and estimation. First is the language. The language students will need to know to be able to be competent using the decomposition algorithm are things like take away 266 from 843, subtract, take away, less than, and difference. These are all words that they'll need to be familiar with. So for example, when they're given a question, if you have 843 sheep and you take away 266 of them to put them in a different paddock, how many sheep will you have? This is the kind of language that they will need to know and will continue to learn. Next are symbols. Symbols the students need to know are the basic subtraction symbol and the equal sign. They should already be aware of what this looks like from their previous knowledge of basic addition and subtraction. Then there comes models. First we've got MAB blocks. Models can be used to help children understand the algorithm. Are MAB blocks as well as popsicle sticks and skewers. The popsicle sticks and the skewers won't come till later on until the children really understand the algorithm and how to use the MAB blocks. Something else that students will need to know is estimation. Students using estimation will help them get an idea of what the answer might be. It is important to know how to round correctly. This should be prior knowledge. Estimation needs to be an ongoing part of children's number work to build an inclination to estimate whenever an approximate result is required, either to suit a particular situation or to check whether the answer is about right. Some common difficulties that students are having with learning level 3 subtractions are difficulties with this algorithm. This is because the focus is on the symbol and the answer, rather than the meaning associated with having a whole and taking away a part. Because there is such a focus on the symbol and the answer, the student doesn't understand that you cannot take away 6 units from 3. This is why you have to choose an appropriate activity for the student to understand the algorithm. Consequently, a child may be unable to give a story to match a picture or symbols. They may rush to give an answer rather than reading the problem, and may not be able to show you the situation using materials. Students will most likely need help understanding that subtracting 110 from the tens column means that they are adding 10 to the ones column. It is assumed that the prior knowledge needed for the students to learn the decomposition method is to be competent in basic addition and subtraction. Based on Victoria Curriculum and Assessment Authority, students should be able to count to and from 1000 and perform simple additions and subtraction calculations using a range of strategies. The students will also need to know how to round numbers to the closest tens and 100s, so they are capable of estimating at the start of the activity. The learning objectives from this activity is how to do the decomposition method, estimation, teaching children the correct model, symbols and language for subtraction, learning and practicing regrouping, and practicing place value. Now to start the activity, you need MAB blocks, texters, and paper. The activity I have chosen is called Stick Fun. This shows the children the place value of each number and how to regroup so they can begin to understand the method, also known as the decomposition method. First step is getting the students to estimate. This is so they have a rough idea of what their answer is going to be. Start off with a sum that's simple. 51 take away 29. Now lay out your MAB blocks on the numbers. 51. Next ask the students, can you take away 9 from 1? Of course not. Tell them you need to regroup the MAB so you can take away the 9. Take one of the group from the numeral 5, turn it into 10 MAB and put it with the 1 MAB so you now have 11. Now you can take away the stick of 10 MAB because you have 10 individual ones. Put them with the 1. You can show the students that you have taken 10 from here and put it here. You now have 11. 11, take away 9. The answer is now 2. And you've got 40, take away 20. You have 20 left. This is a way that helps them understand that borrowing an amount from a higher value and giving it to a lower place value.